to lesson 5.2. It is proving trig identities. Okay. We're going to still, that first page of identities we have in 5.1, we're still going to be referring to that. Okay, we're still going to be using those identities. Our job here is to complete the proof. So it reminds me of what we did in 5.1, where you were simplifying trig identities. But the point there, when you were simplifying identities, I said, well, often these identities will go to like one trig function, but you didn't know what the answer was going to be. So you didn't know if you had it right. You didn't know if you were done. Okay. Proofs, the idea with proofs is that you have the beginning and you have the end, and you know they're equal. The idea of a proof is you put the steps in to show that it's equal. Okay. Now, it's not going to be like a geometry proof or anything where you have to write, like the steps or what, the pieces are. But it's going to be the idea of the filling in the middle. Now, with that in mind, I will tell you, this is one of those homeworks that I check myself because there's no point putting an answer key up. You have the beginning, you have the end. The answer key is what goes in the middle. And what I have in the middle, there's some of these problems where I have it worked out 2 or 3 different ways because of different order of steps, which is why I spend my time checking these. Okay, so just kind of a heads up about that. Okay, so now we're going to start algebra here. Okay, to kind of get the idea of where we're going. So this example 1 asks us to prove the algebraic identity. So no trig for a moment. But x squared minus 1 over x minus 1 minus x squared minus 1 over x plus 1 equals 2. So what I want you guys to consider here is we're going to start with the left. X squared minus 1 over x minus 1 minus x squared minus 1 over x plus 1. Okay, that's our left. We're going to do some work. Our goal at the end is that it equals 2. So the answer is 2. Your job is to fill in the middle. Okay. Now, a lot of time it's just various simplifying steps that you already know. So we're not doing anything wild and crazy. It's steps you already know. We just have to put them together. So somehow this has to equal 2. Thoughts of directions you would like to go here? Okay. And now, what I will say about that, common denominator is the obvious choice, and it will get us there. I think it might take a little more work than a different way if you happen to see a different way. I agree, common denominator is what I would traditionally say too.
Did you factor out the x, like from the numerators? So then you could like positive.
It's not, okay, so let's talk about factoring. It's not factoring out an x. But what do you know about the numerator, x squared minus 1?
Oh, it can be rewritten as x minus 1, x plus 1. So
okay. So x squared minus 1 factors into 2 parentheses, yes? This is what I call the difference of squares. X and x breaks up into, or x squared, breaks into x times x. 1 breaks up into 1 times 1. And how do we get it to multiply to be minus 1? You need a plus and a minus. So this first fraction can be rewritten as x plus 1 times x minus 1 over x minus 1. Minus, what about the second fraction? X squared minus 1 can be rewritten as x plus 1 times x minus 1 over, this time it's over, x plus 1. Now, keep in mind here, with proofs, you're being graded on your work. I know the tendency there sometimes is to try and skip steps. Don't get to skipping too many steps. That's probably, is that it on the back then?
Yeah.
Okay. I was trying to figure out whose stuff that was on the back. I didn't realize you didn't make it back to get your stuff laden. Okay. So, in other words, what I'm saying here is don't get to skipping too many steps. Okay, because I need to be able to see the steps to know that you didn't just guess. It wasn't just magic, that you legitimately understand the math behind it. Okay, so what happens on that first fraction?
X minus 1's cancel.
Okay, so a factor of x minus 1 cancels with a factor of x minus 1. What happens on the second fraction? A factor of x plus 1 cancels with a factor of x plus 1. Okay, so where are we at?
X plus 1 minus X minus 1.
In the first fraction, we have x plus 1. Minus, in the second fraction, we have, I'm going to write it as x minus 1, but I put it in parentheses because we're subtracting that quantity. Now, subtracting that quantity, though, what's it really become?
You distribute the minus.
Yeah, you distribute the minus, and we're going to have x plus 1 still. Then it becomes minus x and
Plus 1.
plus 1. Now what?
It becomes 2.
Does it work?
Yeah. You could rewrite it as x minus x 1 plus 1.
Yeah. The x minus x will cancel, yes? And then that leaves us with 1 plus 1, which is 2. Okay, so Katie made the comment you could rewrite it as x minus x plus 1 plus 1. Do you have to do that, though? No. Okay, that can be my last line of work, because when I clean that up, my brain sees that, and you could do something like this if you wanted to, you wouldn't have to. X minus x cancels, 1 plus 1 is 2. Okay? Is this the only way to work this problem? No. You can go the common denominator route. Now, what I'll tell you with the common denominator route, you end up with higher powers, more terms, which is why, since I heard the word factoring, you could go with that. Okay? But this is why when I look at the ones I have worked out, I have some problems worked out 2 or 3 different ways. Okay? So if you can show me steps that make sense and flow, I'm good with it. Okay? What I need you not doing is don't make me guess, do you really know how that worked? Like, for instance, in this situation, I would not really want you to just start with the original. I wouldn't really want this right here to be your first step. Because I'm going to question, did you know to factor? Or did you just try and do the illegal thing of x squared divided by x and 1 divided by 1? Because that's illegal. That's not, you have to cancel factors. Okay? So showing me that factoring step makes me believe, okay, yes, you got it. Okay, so show me the steps is what I'm saying. Okay, that's your algebra break-in. Now we got to transfer to trig. Okay, so I'm going to start with, okay, what are we starting with? Tan x plus cotan x is what I'm starting with. What is my goal to end up with? Secant x times cosecant x. Okay? And I'm not saying you have to write that goal down there, but I want you to realize that's what you're working towards. Because at the beginning, okay, I'm just trying to think, what can I do to rework this? But as I get closer to the end, I'm going to be kind of looking and saying, okay, how can I make it look like that? Okay? That's going to be my thing at the end. Now, go back to what we did in lesson 1. We were using all those identities. And remember, we kind of had like the 5 ideas of ways you could, simplify things. Those still work, where it was getting a common denominator or splitting a fraction or using Pythagorean identities or using factoring and foiling or changing things to sine and cosine. It all goes back to that list of identities, though. So, and you could even right now say, okay, even if you don't know where we're ending, okay, pretend we don't know that. Tangent plus cotangent. Okay, they're not like terms. I can't add them right now. Could we go to sines and cosines? Yeah. We can. Okay, and here's the deal. Eventually, somehow, these have to add, don't they? notice it's something plus something. It's going to equal just one term in the end. Okay, so tangent, according to our quotient identity. Are you familiar with your identities now? I hope. Tangent is sine x over cosine x, plus cotangent is cosine x over sine x. Okay.
Common denominator.
Okay. Based on what I pointed out, that I have two pieces being added, eventually it has to become one, yes? A common denominator could make that happen. What is our common denominator?
Sine x, cosine x.
Okay, so I have a denominator of cosine, I have a denominator of sine. I don't have anything in common, so smush them together for your common denominator, right? So I'm going to write this as sine x cosine x in the denominator, plus another sine x cosine x in the denominator. And I'll talk in the end about maybe steps that you might skip or something, but okay, first fraction.
Sine x squared.
Okay, it has a cosine. What are we missing? We're missing a sine. So what do we do to the top? You multiply by sine. Sine times sine is sine squared x. Second fraction has a denominator of sine x. What am I missing? Missing cosine x. So that means I'm multiplying bottom and top by cosine x. On top, what is cosine x times cosine x? Cosine squared x. Okay. I chose to write mine as two separate fractions at that point. What would be the natural next step? We got a common denominator, so put it together as one fraction, if you haven't already. So, common denominator is going to be sine x cosine x, right? This is like doing 1/5 plus 2/5. You keep the 5 on the bottom, and then on top, 1 plus 2. Ours is going to be sine squared x plus cosine squared x.
One diagram over.
Numerator, is it popping out to you?
Yep.
I'm still going to use that same statement. Squared trig functions add or subtracted to other squared trig functions and or ones is probably going to fall into the Pythagorean identity category. Sine squared plus cosine squared is 1. So we have 1 on top over sine x cosine x. The only problem with having an ending point is I've run out of room for steps. And all that means is I just erase that and move over if I need to.
I mean, you're done. You can rewrite that as.
Do I need another step or am I done?
You're done.
Okay. What, do you guys understand the connection here? Okay. This is 1 over sine x cosine x. A sine x in the denominator is equivalent to a cosecant x in the numerator. Do we have that piece? Yeah. A cosine x in the denominator is equivalent to a secant in the numerator. Are we there?
Yeah.
Yeah, you can consider yourself there. Okay. Now, would some people possibly put another step and break it into the pieces? You could. Okay, I've seen people say, okay, 1 over sine x, and then make it cosecant x, 1 over sine x and make it cosecant, times 1 over cosine, make it secant. But you don't have to do that. Okay, we're there. Okay, now, I obviously showed I was multiplying by sine and cosine. You wouldn't necessarily have to write that piece in. Okay, depending on your skill level, Could you go ahead and jump to one fraction with the common denominator? You could. Okay, so there's places where you could change your steps just slightly, but don't change so many steps that I have no idea what happened. Because if I have no idea what happened, okay, either one, you really just rocked that problem and you knew exactly what you were doing, or B, you had no clue what you were doing and you just flubbed yourself along and tried to make it look like you knew what you were doing. Because there will be times that will happen. You know the beginning, you know the end, you don't know the exact middles, you'll try to put some pieces and make me believe. Don't make me question if I have to believe, okay? Because that's when you're likely to lose points if I have to question. Do I believe them? Okay? Okay. We followed that one though, right? Does that seem like stuff we did back in lesson 1? I mean, it does to me. The difference is I know where I'm ending. Okay. Ready to try 3? As ready as it gets? Okay. Three. Ask us to prove the identity. So let me write out my beginning pieces. 1 over secant x minus 1 plus 1 over secant x plus 1 equals, and what's my goal at the end? Okay. That's my goal. I have to make the pieces in the middle happen. Okay. Thoughts on where to begin?
Find the common denominator.
There are 2 fractions being added that if you look ahead towards the answer are going to become 1 term. That means at some point we have to add them, yes. Okay. I'm going to get it out of the way now. Could I talk Pythagorean identities in those denominators?
No.
No, why not?
It's not squared.
It's not squared, yes? That's a common mistake, so I'm just trying to stop that mistake. Okay, so what is our common denominator?
Secant x minus 1, secant x. Can you just read it?
Okay, so secant x minus 1, secant x plus 1. Do they have anything in common? I mean, they have a secant, but yet not that we can share. So our common denominator is secant x plus 1 times secant x minus 1. For right now, because we're in this first step, I'm going to write it as secant x minus 1 times secant x plus 1. Katie was asking, could we distribute? You could. Okay, you can also wait and see what happens. I'm just trying to get us set up right now. Okay, so okay, common denominator, secant x minus 1, secant x plus 1. In the first fraction, it was secant x minus 1. What am I missing?
Secant x plus 1.
Secant x plus 1. So what am I multiplying the top by? Secant x plus 1. What is 1 times secant x plus 1?
Secant x plus 1.
Secant x plus 1? Okay. Second one. Denominator is secant x plus 1. What are we missing? You're missing a secant x minus 1. So what do we multiply the top by? Secant x minus 1. What is 1 times secant x minus 1? Secant x minus 1. Okay. We got a common denominator. What should we do? Put them together with that common denominator, yes?
Are you allowed to skip this step? Just rewrite them all as one.
Say what now?
So like skip the one that you just did. Just go ahead.
Oh, and go ahead and put it all as one fraction?
Yeah.
As long as I can see the pieces.
Okay.
Okay, so I'm going to go ahead and write my denominator as secant x minus 1 times secant x plus 1. I'll talk about what steps I would be okay with skipping here in a moment, how. If we put this together, okay, denominator is the same. Numerator, secant x plus 1 plus secant x minus 1. What do we get when we put our numerators together? No?
Secant x plus 1 times secant x plus secant x plus 2.
No.
Secant x plus 1 plus secant x minus 1.
I'm going to...
2 secant
Okay.
Yeah.
I wasn't necessarily going to write this step out here, but we're having small issues visualizing here. Okay, so you could skip what I just wrote on top. Well, hold on. I'll talk about this more in a moment, I guess. But on top, secant x plus 1 plus secant x minus 1. What does that numerator clean up to be? 2 secant x. 1 secant x plus 1 secant x is 2 secant x. And then plus 1 minus 1, cancel. So on top, what do I have here? 2 secant x. Are you with me there?
Yes.
Okay. Now, denominator. Katie mentioned earlier, do we multiply it? Do we not? And that's one of those things you have to decide. When you multiply secant x minus 1 and secant x plus 1, you realize you're multiplying what I call conjugates. They have opposite signs in there, yes?
Yeah.
So what should we do here? Should we multiply? If I'm multiplying conjugates, basically we're going to FOIL. First and last are going to be there, but outer and inner are going to cancel.
Would it just be secant x minus 1 squared?
Say that again?
Secant x minus 1 and then in parentheses.
No.
Secant squared x minus 1?
Well, we're going to FOIL here. Secant times secant is secant squared x. And then secant x times 1, 1 secant x. And then minus 1 times secant x is minus secant x. So what happens with your outsides and insides? They're canceling. Minus 1 times positive 1 is minus 1. Okay?
Oh, the bottom can go to cotangent. It's a Pythagorean identity. So wait. Tangent.
The denominator is secant squared minus 1. So it's a trig function squared minus 1. Think Pythagorean identity. We have a Pythagorean identity. Do I need it? That is 1 plus tangent squared equals secant squared x, right? So secant squared minus 1 is going to be equal to tangent squared. So let's go ahead and change that out to make it 2 secant x over tangent squared x. Okay. Now, this is where we kind of pause, or at least I do, and I say, okay, what am I supposed to be working towards? And where am I at? I'm supposed to be working towards no fractions. I'm I'm supposed to be working towards a secant on, or a cotangent cosecant. Right now I have a secant on top and a tangent squared on bottom. Okay. A couple different ways I'd be willing to talk here.
Oh, do you rewrite the bottom as sine? I mean, you could rewrite the bottom as sine squared x over cosine squared x, and then the top is 2 over 1 cosine x. Is that canceling?
Okay. So at some point, my recommendation is going to be, yes, let's take it all to sines and cosines. Whether we do it now or whether we do it in a moment, okay? Either or. But we're going to have to go to sines and cosines to get this to see, do we have the right pieces here? Now, the one thing I would maybe suggest, I'm not saying you'd have to do this, because if you go ahead and change it to all sines and cosines and manipulate stuff around, it would be good. But the other thing, if we want to get this out of fraction form, what is a tangent in the denominator? It's a cotangent up top, yes? So tangent squared in the denominator, can I move it to cotangent squared up top? You could, and then we just avoid the dividing issue. That's the only thing I'm doing here. So I could rewrite this as 2 secant x, and then tangent squared on the bottom becomes cotangent squared up top. And that's because they're reciprocals, yes?
Yeah.
Now, at this point, I would definitely, we see a cotangent, right? But we have an extra cotangent. I'm missing the cosecant. I would change everything to sines and cosines and get it to map out that way. There's your proof that we have all the right pieces. So the 2 is good. 2 is 2. What do you know about secant? You guys there? Secant, if we're going to all 2 tangents and cotangents, I guess I could make this 2 over 1, but secant is 1 over cosine x. What do you know about cotangent?
Cosine squared x over sine squared x.
Okay, cotangent is cosine over sine. Since this is cotangent squared, this is going to be cosine squared x over sine squared x. Okay. Well, what's one thing you see that can happen?
One of your cosines cancels the bottom cosine.
Cosine the denominator cancels with 1 cosine on top, yes? And here's the deal. We know we have the 2 out front, yes?
Yeah.
I have cosine over sine squared length. How could I rewrite that to make that look like what I need it to be? Or is it what I need it to be? What is cotangent?
Cosine over sine.
Cosine over sine. What is cosecant? 1 over sine. Do I have an extra sign there?
Yeah.
Yeah.
Oh.
Okay, so I have basically a cosine on top, and if I take that sine on bottom and break it into sine x times sine x, you can just put that as 1. Do we have all the pieces we need?
Yeah.
Okay, and so this is where I'm just trying to suggest, this is where you kind of work forwards and backwards at the same time. Okay, I know I need a cotangent. Okay, I got cosine, I got sine. I know I need a cosecant. Okay, I got an extra sign in the denominator. And now it's 2 times cotangent times cosecant, and it works. Okay. Pieces, okay? So like when we go back up here and look at the top, I wrote it as 2 fractions first. My actual plan was to then put it together and make it 2 secant x, but we weren't quite there. So I took an extra step there, okay? At some point, you want to multiply. Out of these first 3 steps, could we eliminate one of those steps? Probably. Now, what I would not suggest you do I guess what I'm saying is at some point I would like to see written out, whether it be the first or second step, where I can see the secant x plus 1 and the secant x minus 1 before you actually put it together, before it gets canceled. Now, maybe you just jumped right to this step and skipped this first row. I'm fine with that. Okay? It's making me believe. Make a believer out of me, right? Okay. And like everything else we've done so far this chapter, the hard part is going to be making this happen on your own, right? Piece of cake when the teacher can lead you through it. Or when you have your peers helping you along, right? Okay. Example 4. Wasn't sure how far we'd get, and I obviously forgot to blow that page up. So, okay, so I'm starting with cosine t over 1 minus sine t. And my job is to make it one plus sine t over cosine t.
You wouldn't get the 1 minus sine t out of the denominator?
Well, I'm not sure we have a legal way to do that right now. How are you proposing getting 1 minus sine t out of the denominator?
I don't really know, actually.
Okay. Because, and here's what I'm going to tell you. You can't just say, oh, the reciprocal of sine is cosecant, now there's a cosecant on top. That doesn't work because this is not just a sine, it's a 1 minus sine. Okay? This is one, I don't know if I'm not sure we've done one exactly like this. I cannot change it to tangent because what's throwing the kink in things? That silly 1, right? Okay. I can't really put that cosine, I can't put the pieces, that 1 minus sine. That's a problem.
Let's get rid of it.
Let's what?
Get rid of it.
Get rid of it?
The island.
Boot it off the island? If only it was that easy, right?
Can you, is there a way you can get under 1 and then it would keep this which component of it? No, you can't. Okay, no, I don't know.
But it's still going to be in the denominator. Yeah, it's still going to be there.
I don't know.
Okay. So 1 minus sine t. It's a problem child, right?
Yeah.
Okay. So we have done this in other stuff at times. But what if I suggest multiplying by the conjugate of the denominator? Now, do you remember the vocab word conjugate?
1 plus.
Right. It's keeping the terms the same, but but changing that middle sign. So meaning, since it's a 1 minus sine t, let's multiply by 1 plus sine t. Now, what am I going to say? Whatever you do to the denominator, you have to do to the numerator. We have to keep the fraction equivalent. On top, it's just cosine times 1 plus sine t. You could possibly distribute. I'm trying to figure out in my head where this is going. I'm not sure I would necessarily jump to distribute here until I see what's going on. Okay? Just because so often we end up factoring out a GCF. So, now, here's the deal. If you do distribute it, can you undo it at any given time? Yeah. Now, the denominator. That denominator was the problem child. What happens when I multiply these denominators? How do I multiply these denominators?
Oh, it becomes, okay, that's what distributing.
Okay. 1 times 1 is 1. 1 times sine t, sine t. Negative sine t times 1, minus sine t. So what just happened? Plus sine t minus sine t. And when it's a conjugate, your outsides and insides cancel. What's last?
1 minus sine squared t.
Minus sine t times positive sine t is going to be a minus sine squared t.
Oh, cosine t. Or cosine squared t.
What's she talking about?
Pythagorean identity.
Do you see a Pythagorean identity?
Yes.
Pythagorean identity.
I love those.
Sine squared theta plus cosine squared theta is equal to 1. Well, if we subtract the sine squared theta over, we end up with cosine squared theta equals 1 minus sine squared theta. So, numerator is still cosine t times 1 plus sine t. I haven't changed that yet. Denominator, 1 minus sine squared t can be replaced with cosine squared t. That is a Pythagorean identity move.
Cancel one of your cosines. Or cancel one of your cosines on the bottom and your cosine on top.
Okay, can I do that?
Yeah.
Because cosine squared, cosine is cosine on the bottom. On top, cosine is a factor, right?
Yes.
It's cosine times the rest, so I can cancel since it's cosine times. So cosine on top cancels with one of my cosines on bottom. What remains?
1 plus sine t over cosine t.
1 plus sine t over cosine t. And I got there with extra space to spare. Okay?
Is it okay? Like, I don't like working with variables other than x, mostly because I just have bad handwriting and can't see it. So is it okay if I just switch t to x? Might work.
I'm okay with that. Okay. Make sure you have a variable in there. That's a definite. Don't just make it cosine and sine and don't have any variable in there. We need some variable in there. So, yeah, I see that happen every year where some of you stick with the x's, the t's, the thetas. Some of you just like, nope, and you just everything automatically becomes an x. So that is an option. Okay? I'm not going through example 5 in 4 minutes. It's not happening. So that'll be a good one to talk about tomorrow.
While we're eating pie.